Welcome to CO556 Network Systems. This is week 10 and this is chapter 13 of the Cisco syllabus, and this week we're looking at WLAN configuration. The objective for this week is to implement a WLAN using a wireless router and wireless link controller or LAN controller. We're going to configure a wireless LAN to support a remote site, configure a wireless LAN controller for a wireless LAN to use the management interface and WPA2 PSK, pre-shared key authentication. And we're going to configure a wireless LAN controller for a WLAN to use a VLAN interface and a DHCP server and WPA2 enterprise authentication. And then we're going to troubleshoot some common wireless configuration issues. Remote site WLAN configuration. The wireless router. Remote workers, small branch offices, and home networks often use a small office and home router. These integrated routers typically include a switch for wired clients, a port for an internet connection, sometimes labeled WAN, and wireless components for wireless client access. These wireless routers typically provide WLAN security, DHCP services, integrated name address translation, NAT, quality of service, QoS, as well as a variety of other features. The feature set will vary depending on the router model. Note, cable or DSL modem configuration is usually done by the service provider's representative, either on-site or remotely. Log in to the wireless router. Most wireless routers are pre-configured to be connected to the network and provide services. Therefore, your first priority should be to change these defaults for security reasons. To gain access to the wireless router's configuration GUI, open a web browser and enter the default IP address for your wireless router. The default IP address can be found in the documentation that came with the wireless router, or you can search the internet. The word admin is commonly used as a default username and password. Basic network setup. Basic network setup includes the following steps. Log in to the router from the web browser. Change the default administrative password. Log in with the new administrative password. Change the default DHCP IP version 4 addresses. Renew the IP address. Log in to the router with the new IP address. Basic wireless setup includes the following steps. View the WLAN defaults. Change the network mode, identifying which 802.11 standard is to be implemented. Configure the SSID. Configure the channel, ensuring there are no overlapping channels in use. Configure the security mode, selecting from Open, WPA2, WPA, Personal, or WPA2 Enterprise. Configure the passphrase as required for the selected security mode. Configure a wireless mesh network. In a small office or home network, one wireless router may suffice to provide wireless access to all the clients. If you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you create a wireless mesh. Create the mesh by adding access points with the same settings, except using different channels to prevent interference. Extending a WLAN in a small office or home has become increasingly easier. Manufacturers have made creating a wireless mesh network, a WMN, simple through smartphone apps. NAT for IP version 4. Typically, the wireless router is assigned a publicly routable address by the ISP and uses a private network address for addressing on the LAN. To allow hosts on the LAN to communicate with the outside world, the router will use a process called network address translation, or NAT. NAT translates a private local source IP version 4 address to a public global address. The process is reversed for incoming packets. NAT makes sharing one public IP version 4 address possible by tracking the source port numbers for every session established by a device. If your ISP has IP version 6 enabled, you will see a unique IP version 6 address for each device. Quality of service. Many wireless routers have an option for configuring quality of service, QoS. By configuring quality of service, you can guarantee that certain traffic types such as voice and video are prioritized over traffic that is not as time sensitive, such as email and web browsing. On some wireless routers, traffic can be prioritized on specific ports. Port forwarding. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of the LAN. However, there are situations when specific ports must be opened so that certain programs and applications can communicate with devices on different networks. Port forwarding is a rule-based method for directing traffic between devices on separate networks. Port triggering allows the router to temporarily forward data through inbound ports to a specific device. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. We have a packet tracer exercise called Configure a Wireless Network. The objectives for that exercise are to connect a wireless router, configure the wireless router, connect a wired device to the wireless router, connect a wireless device to the wireless router, add an AP access point to the network, and to extend wireless coverage. Update the default router settings. You should do that packet tracer now before configuring. Continuing on with the work. Configure a basic WLAN on the wireless link LAN controller. Wireless LAN controller topology. The topology and addressing scheme used for this topic are shown in this figure here, in the table. The access point, AP, is a controller-based access point as opposed to an autonomous access point, so it requires no initial configuration and is often called a lightweight access point, or LAPs. Lightweight access points use the Lightweight Access Point Protocol to communicate with a WLAN controller. Controller-based access points are useful in situations where many access points are required in a network. As more access points are added, each access point is automatically configured and managed by the WLAN controller. Log into the WLAN controller. Configuring a wireless LAN controller is not much different from configuring a wireless router. The wireless LAN controller controls access points and provides more services and management capabilities. The user logs into the wireless LAN controller using credentials that were configured during initial setup. The network summary page is a dashboard that provides a quick overview of configured wireless networks, associated access points, and active clients. You can also see the number of rogue access points and clients. View access point information. Click Access Points from the left menu to view an overall picture of the access point system and information and performance. The access point is using IP address 192.168.200.3. Because a Cisco Discovery Protocol, CDP, is active on this network, the wireless LAN controller knows that the access point is connected to the fast Ethernet 01 port on the switch. This access point in the topology is a Cisco ErrorNet 1815i, which means you can use the command line and a limited set of familiar iOS commands. Advanced settings. Most wireless LAN controllers will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. However, as a network administrator, you will typically access the advanced settings. For the Cisco 3504 wireless controller, click Advanced in the upper right-hand corner to access the advanced summary page. From here, you can access all the features of the WLAN controller. Configure a WLAN. Wireless LAN controllers have Layer 2 switch ports and virtual interfaces that are created in software and are very similar to VLAN interfaces. Each physical port can support many access points and WLANs. The ports on the wireless link LAN controller are essentially trunk ports that can carry traffic from multiple VLANs to a switch for distribution to multiple access points. Each access point can support multiple WLANs. Basic WLAN configuration on the wireless LAN controller includes the following steps. Create the WLAN. Apply and enable the WLAN. Select the interface. Secure the WLAN. Verify the WLAN is operational. Monitor the WLAN and view wireless client information. Creating the WLAN. In the figure here, a new WLAN with an SSID name wireless_LAN is created. Applying and enabling the WLAN, we next see that the WLAN is enabled and the WLAN settings are configured. In the third step, we select the interface. The interface that will carry the WLAN traffic must be selected. Step 4, securing the WLAN. The Security tab is used to access all the available options for securing the WLAN. In step 5, verifying the WLAN is operational, the WLAN's menu on the left is used to view the newly configured WLAN and its settings. In step 6, monitoring the WLAN, the Monitor tab is used to access the advanced summary page and confirm that wireless LAN now has one client using its services. In step 7, we view the wireless client details. We click Clients in the left menu to view more information about the clients connected to the WLAN. We have a packet tracer on this, which is called Configure a Basic WLAN on the Wireless LAN Controller. And in that lab, you explore some of the features of the Wireless LAN Controller. So you create a new WLAN on the controller and implement security on the LAN. Then you get to configure a wireless host to connect to the new WLAN through an access point that is under the control of the Wireless LAN Controller. Finally, you verify the connectivity. Configure a WPA2 Enterprise WLAN on the Wireless LAN Controller. SNMP and Radius. PCA in this diagram is running Simple Network Management Protocol, SNMP, and Remote Authentication Dial-in User Service, which is Radius, a server software. The network administrator wants the wireless LAN controller to forward all SNMP log messages, i.e. traps, to the SNMP server. The network administrator wants to use Radius server for authentication, authorization, and accounting, AAA services. Users will enter their username and password credentials, which will be verified by the Radius server. The Radius server is required for WLANs that are using WPA2 enterprise authentication. Note SNMP server and Radius server configuration is beyond what we can do within the module. Configuring SNMP server information. To enable SNMP and to configure the settings, click the Management tab to access a variety of management features. Click SNMP to expand the submenus, click Trap Receivers, and then click New to configure new SNMP trap receiver. Enter the SNMP community name and the IP address, IP version 4, IP version 6, for the SNMP server, and then click on the Apply. The wireless LAN controller will now forward SNMP log messages to the SNMP server. Configure Radius server information. To configure the wireless LAN controller with the Radius server information, click Security, click Radius, click Authentication, then click New to add PCA as the Radius server. Enter the IP version 4 address for PCA and the shared secret will then be used between the WLAN controller and the Radius server, and then click on Apply. Configure Radius server. After clicking Apply, the list of configured Radius authentication servers refreshes with the new server list. Topology with VLAN 5 addressing. Each WLAN configured on the wireless LAN controller needs its own virtual interface. The wireless LAN controller has 5 physical data ports that can be configured to support multiple WLANs and the virtual interface. The new WLAN will use interface VLAN 5 and the network of 192.168.5.0/24, and therefore R1 has been configured for VLAN 5 as shown in this topology, and show IP interface brief output. Configure a new interface. VLAN interface configuration on the wireless LAN controller includes the following steps: create a new interface, configure the VLAN name and ID, configure the port and interface address, configure the DHCP server address, apply and confirm, and verify interfaces. Creating a new interface. Click on Controller, Interfaces, and then New. You can configure the VLAN name and ID. In this example, the new interface is named VLAN 5, and the VLAN ID is 5, and applied. Configuring the port interface address. On the interface edit page, configure the physical port number, i.e. WLC G1 interface is port number 1 on the wireless LAN controller. The VLAN 5 interface addressing, i.e. 192.168.5.254/24, and the default gateway, i.e. 192.168.5.1. Configure the DHCP server address. The example here configures a primary DHCP server at IP version 4 address 192.168.5.1, which is the default gateway router address, which is enabled as a DHCP server. Apply and confirm, scroll to the top and click Apply, and then click OK for the warning message. Verify interfaces. Click Interfaces to show that the new VLAN 5 interface is shown in the list of interfaces with its IPv4 address. Configure a DHCP scope. The DHCP scope configuration includes our following steps: create a new DHCP scope, name the DHCP scope, verify new DHCP scope, configure and enable new DHCP scope, and then verify enable DHCP scope. So, configuring a DHCP scope, create a new DHCP scope. To configure the new DHCP scope, click Internal DHCP Server, and then DHCP Scope, and New. Name the DHCP scope. The scope is named wireless_management, and then applied. Verify the new DHCP scope. In the DHCP scopes page, click the new DHCP scope name to configure the DHCP scope. Configure and enable the new DHCP scope. On the edit menu for the wireless_management scope, configure a pool of addresses, i.e. 192.168.200/24/249. The default router IP version 4 address, i.e. 192.168.200.1, then enabled and apply. Verifying the enabled DHCP scope, the network administrator is returned to the DHCP scope pages and can verify the scope is ready to be allocated to a new WLAN. By default, all newly created WLANs on the WLC will use WPA2 with Advanced Encryption System, AES. 802.1x is the default key management protocol used to communicate with the Radius server. Next, create a new WLAN to use interface VLAN 5. Configuring a new VLAN or WLAN on a wireless LAN controller includes the following steps: creating a new WLAN, configuring the WLAN name and SSID, enabling the WLAN for VLAN 5, verifying AES and 802.1x defaults, configuring the WLAN security to use the Radius server, and verifying the new WLAN is available. First, we create a new WLAN, which we click WLANs tab, and then go to create the new WLAN. Configuring the WLAN name and SSID, enter the profile name and SSID, choose an ID of 5, and then click Apply to create the new WLAN. Enable the WLAN for VLAN 5. Once the WLAN change the status to enabled, choose VLAN 5 from the interface group drop-down list, and then click Apply and click OK to accept the pop-up message. Verify AES and 802.1x defaults. Click the Security tab to view the default security configuration for the new WLAN. Configure the radius server. To select the radius server that will be used to authenticate WLAN users, click the AAA Servers tab, and in the drop-down box, select the radius server that was configured on the wireless LAN controller previously, and then apply your changes. Verify that the new WLAN is available. To verify that the new WLAN is listed and enabled, click on the WLAN submenu. We have a packet tracer exercise to configure a WPA2 Enterprise WLAN on the wireless LAN controller. So in that packet tracer activity, you will configure a new WLAN on a wireless LAN controller, including the VLAN interface that it will use. You will configure the WLAN to use a radius server and WPA2 Enterprise to authenticate users. You will also configure the WLC to use SNMP server. So the steps will be to configure a new VLAN interface on a WLC, configure a new WLAN on a WLC, and configure a new scope on the WLC internal DHCP server, configure the WLC with SNMP settings, configure the WLC to use radius server to authenticate WLAN users, secure WLAN with WPA2 Enterprise, and connect hosts to the new wireless LAN controller. Troubleshoot WLAN issues. Troubleshooting approaches. Network problems can be simple or complex, and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This process is called troubleshooting. Troubleshooting any sort of network problem should follow a systematic approach. A common and efficient troubleshooting methodology is based on the scientific method and can be broken into 6 main steps shown in the next table on our next slide. So, the 6 steps. Identify the problem. The first step in the troubleshooting process is to identify the problem. While tools can be used in this step, a conversation with the user is often very helpful. Step 2. Establish a theory of probable causes. After you've talked to the user and identified the problem, you can try and establish a theory of probable causes. This step often yields more than a few probable causes to the actual problem. In step 3, test the theory to determine cause. Based on the probable causes, test your theories to determine which one is the cause of the problem. A technician will often apply a quick procedure to test and see if it solves the problem. If a quick procedure does not correct the problem, you might need to research the problem further to establish the exact cause. In step 4, establish a plan of action to resolve the problem and implement the solution. After you've determined the exact cause of the problem, establish a plan of action to resolve the problem and implement the solution. Step 5, verify full system functionality and implement preventative measures. After you've corrected the problem, verify full functionality and, if applicable, implement preventative measures. In step 6, the final step, document findings, actions, and outcomes. In the final step of the troubleshooting process, you document your findings, actions, and outcomes. This is very important for future reference. Wireless client not connecting. If there is no connectivity, check the following. Confirm the network configuration on the PC using the ipconfig command. Confirm that the device can connect to the wired network. Ping a known IP address. If needed, reload drivers as appropriate for the client, or try a different wireless network interface card. If the wireless network interface card of the client is working, check the security mode and encryption settings on the client. If the PC is operational but the wireless connection is performing poorly, check the following. Is the PC out of the planned coverage area? Check the channel settings on the wireless client. Check the interference with the 2.4 GHz band. Next, ensure that all devices are actually in place. Consider a possible physical security issue. Is there power to the devices, and are they powered on? Finally, inspect links between cabled devices looking for bad connectors or damaged or missing cables. If the physical plant is in place, verify the wired LAN by pinging devices including the access point. If connectivity still fails at this point, perhaps something is wrong with the access point or its configuration. When the user PC is eliminated as the source of the problem and the physical status of the devices is confirmed, begin investigating the performance of the access point. Check the power status of the access point. To optimize and increase the bandwidth of 802.11 dual band routers and access points, either upgrade your wireless clients. Older 802.11b and 802.11g and even 802.11n devices can slow the entire WLAN. For the best performance, all wireless devices should support the same highest acceptable standard. Split the traffic. The easiest way to improve wireless performance is to split the wireless traffic between 802.11n 2.4 GHz and the 5 GHz band. Therefore, 802.11n or better can use the two bands as separate wireless networks to help manage the traffic. There are several reasons for using a split the traffic approach. The 2.4 GHz band may be suitable for basic internet traffic, which is not time sensitive. The bandwidth may still be shared with other nearby WLANs. The 5 GHz band is much less crowded than the 2.4 GHz band, ideal for streaming multimedia. And the 5 GHz band has more channels, therefore the channel chosen is more likely interference-free. By default, a dual band routers and access points use the same network name on both the 2.4 GHz band and the 5 GHz band. It may be useful to segment the traffic. The simplest way to segment the traffic is to rename one of the wireless networks. To improve the range of the wireless network, ensure the wireless router or access point location is free of obstructions such as furniture, fixtures and tall appliances. These block the signal, which shortens the range of the WLAN. If this still does not solve the problem, then a Wi-Fi range extender or deploying a powerline wireless technology may be used. Updating firmware. Most wireless routers and access points offer upgradable firmware that should be periodically verified. On a wireless LAN controller, there will most likely be the ability to upgrade the firmware on all access points that the wireless LAN controller controls. In the figure here, the firmware image that will be used to upgrade the access points is downloaded. On a Cisco 3504 wireless controller, we click Wireless Access Points, Global Configuration, and then scroll to the bottom of the page for the access point image pre-download section. We have another little packet trace exercise for troubleshooting WLAN issues. So in the packet tracer, you get to complete the following objectives: troubleshoot wireless LAN connectivity issues in the home network, troubleshoot wireless LAN connectivity issues in an enterprise network. We also have a packet tracer exercise for WLAN configuration. And in that exercise, you get to configure both a wireless home router and a wireless LAN controller based network. You will implement both WPA2 pre-shared key and WPA2 enterprise security. Configure a home router to provide Wi-Fi connectivity to a variety of devices. Configure WPA2 PSK security for home router. Configure interfaces on the wireless LAN controller. Configure WPA2 pre-shared key security on WLAN and connect hosts to the WLAN. Configure WPA2 enterprise on a WLAN and connect hosts to the WLAN and then verify connectivity. What did we learn? Remote workers, small branch offices and home networks often use a wireless router, which typically include a switch for wired clients, a port for an internet connection, sometimes labeled WAN, and wireless components for wireless client access. Most wireless routers are pre-configured to be connected to the network and provide services. The wireless router uses DHCP to automatically provide addressing information to connected devices. Your first priority should be to change the username and password for your wireless router. If you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can add wireless access points. The router will use a process called network address translation, NAT, to convert private IP version 4 addresses to internet routable IP version 4 addresses. By configuring quality of service, you can guarantee that certain traffic types, such as voice and video, are prioritized over traffic that is not as time sensitive, such as email and web browsing. Lightweight access points, LAPs, use the Lightweight Access Point Protocol to communicate with a WLAN controller. Configuring a wireless LAN controller is similar to configuring a wireless router, except that the WLC controls access points and provides more services and management capabilities. Use the WLAN controller interface to view an overall picture of the access point system information and performance to access advanced settings and to configure the WLAN. SNMP is used to monitor the network. The wireless LAN controller is set to forward all SNMP log messages called traps to the SNMP server. For WLAN user authentication, a radius server is used for authentication, accounting and auditing, AAA services. Individual user access can be tracked and audited. Use the wireless LAN controller interface to configure SNMP server and radius server information, VLAN interfaces, DHCP scope, and the WPA to Enterprise VLAN, WLAN. There are 6 steps to the troubleshooting process. When troubleshooting a WLAN, a process of elimination is recommended. Common problems are no connectivity and poorly performing wireless connection when the PC is operational. To optimize and increase the bandwidth of 802.11 dual band routers and access points, either upgrade your wireless clients or split the traffic. Most wireless routers and access points offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers, as well as security vulnerabilities. You should periodically check the router or access point for updated firmware.